Hi and welcome back. So in this video, I just want to talk about scientific notation. So I'll write that down. Scientific notation. And I want to talk about it because one of the things that we're going to be doing in this playlist, in the chemistry playlist, is we're going to be using scientific notation a lot. And it's because scientific notation is very useful for, it does three things very well. It represents really big numbers, so it's for really big numbers. And I'm talking about not like, like you might think, a million. A million is definitely a big number, but we can use scientific notation to represent numbers that we would be drawing zeros all day. We would be drawing lots and lots of zeros, and the zeros would trail off of the page. Scientific notation is good for helping us represent really, really, really big numbers. And when we're talking in chemistry, we're going to be talking about, the number of atoms in a given sample of aluminum, or the number of atoms, or the number of molecules in a beaker of water, or something like that. So you can imagine that we're going to have some really big numbers. So that's the first thing that scientific notation is really good at. The next thing is for, you can probably guess, really small numbers. So this is, conversely, if we said that we had, 0.000001, if we had, 0.00001 grams or some other unit, it takes a while to write out all of these zeros. So scientific notation helps us manage these zeros very effectively. And the last thing that scientific notation does that's going to be very helpful in chemistry, and this might be a confusing concept for you right now, and if it is, I'll definitely explain it more further on in the playlist, probably in the very next video actually. But it's very good at keeping track of our significant figures. And this might, hopefully, this might be confusing for you right now, and I'll definitely explain this concept more in another video. But for right now, it's just important to know that scientific notation, it's good for dealing with really big numbers, for really small numbers, and also for keeping track of how many significant figures we have in a given calculation. So anyway, there's, I guess, the introduction to scientific notation, and you might be asking, well, what is scientific notation? So I'll just go ahead and do a bit of an example. So let's say we had 1,700,000, let's say, dollars. Let's say we had that much money. And I don't have that much money, but let's imagine that we had that amount of money, and let's say we were getting tired of writing all of these zeros because really the only two digits in this, they're actually giving us information about how much money we have in terms of actually telling us something specific in terms of not just showing us the amount multiplied by 10 of how much money we have, but showing us a specific amount. There are really only two digits, right? That we have this 1, we have 1 of something, and then we have 0.7 of something else. So we are able to represent this using much more space, and actually with this example we might not be saving a lot of space. But what we are able to do is we are able to represent this as 1.7 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th. And you might be wondering, well, where does this 6 come from? And you might have seen I just counted over the decimal places. Pretty much where the 6 is from is the 6 is going to be the number of spaces, if we wanted to represent this number, the number of spaces we would be moving this decimal point to the right. So you can imagine, okay, let's say I have 1.7 and I'm going to put all these zeros after it. 1.7000000, and we're going to multiply this times 10 raised to the sixth. And you can imagine that if we multiply something by 10 raised to the sixth, if we were just, actually this might be a good exercise to do. What's 10, I'll write down, what's 10 to the first power? So what is 10 to the first power equal to? And this might be, you know, you might think, well, this is pretty simple. It's just 10, right? Because anything raised to the first power is just that same number. And that's right. How about what is 10 squared? Well, that's going to be 10 times 10. That's 100. What's 10 cubed? 10 cubed is going to be 100 times 10. So we just add on another 0. And hopefully you can see where the pattern is going. If we had 10 to the fourth, we would just take 10 to the third and we would add on another 0. Or another way to think about it is this exponent, and this is really where scientific notation directly comes from. This exponent of 10 raised to the fourth power is just the number of zeros that we're going to add on to our exponent. So anyway, if we were going to represent 1.7 million in scientific notation, we would say 1.7 times 10 raised to the sixth power. So that way, we would know if we were going to move, let's say, and I've written out 1.7000000 times 10 to the sixth. If we were actually going to multiply this 10 to the sixth into this, we would just be moving our decimal point over, right? We would just move this decimal point over 6 places. So let's just see what that would look like. We would move it over once, twice, 3 times, 4 times, 5 times, and then 6 times. So then our number would be exactly what we expect it to be, is 1,700,000, which is exactly what we started with. So anyway, this might have seemed like it's a bit trivial, but you can imagine one of the really important numbers in chemistry, and we'll definitely go into this more further on in the playlist, but one of the really important numbers that we talk about in chemistry, and I'll do a whole video on this explaining it, but it's Avogadro's number, which is 6.022 times 10 to the 23rd power. So this is, how many zeros is this going to have? And you can imagine, well, it's not, it's going to be, they're going to be zeros, but I guess the better question is, how many spaces are we going to move this decimal place over to the right? Well, it'll be 23 places. So if we were going to write that out, it would be 6022. So our decimal place has already moved 1, 2, 3. And so now it has to move 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and you get the point. We have tons and tons of zeros. They just keep on going, and we would be writing zeros all day. So therefore, scientific notation makes it much easier to write something like this, something like 6.022 times 10 to the 23rd. And this is a number that we will be dealing with a lot in the chemistry playlist. So you could imagine that if we were going to write out 23, or I guess it's actually 20 zeros, after this number, every single time we would have to use it, it would take us, you know, chemistry is supposed to last 1 semester. You can imagine if we had to write all these zeros out, it would take us, 5 semesters to get through a chemistry course, because we spent all of our time just writing zeros into our notebooks. So anyway, I'm actually almost out of time in this video. Actually, you know what? I think I can keep. I'll just keep going in this video, because I also want to cover. So this number right here, this is a really large number. What can we do if we have a really small number? So we had this up here that said 10 raised to the first power is 10, 10 to the second is 100, 10 to the third is 1,000. What if, how about this? First off, what's 10 to the 0 power? And hopefully you realize, and this is also a good time to mention that one of the things you should definitely know before starting a chemistry course is definitely have a good solid mastery over your rules of laws of exponents. And if you don't feel like you have that, definitely go to the Khan Academy and watch some videos on exponents, because they'll definitely help you out getting through a chemistry course. But for right now, hopefully you realize anything raised to the 0 power is just going to be 1. So therefore, if we had, let's just say we had 5.34 times 10 to the 0 power. If we were just going to write that without scientific notation, this would just be 5.34. We just multiply. It's the same thing as just multiplying by 1. How about, what is 10 to the minus 1 power? And hopefully you realize that if you raise something to a negative exponent, that's the same thing as taking the reciprocal. So this is going to be the same thing as 1 over 10 to the 1. So 1 over 10 to the 1, which is the same thing as 1 over 10. And if we were going to write that as a decimal, it's 0.1. So let's imagine what would, if we had this number 5.34, let's take another example. 5.34 times 10 to the minus 1. What would this look like if we were just going to write this without scientific notation? Well, in this example, our decimal point went to the right. So here, our decimal point is just going to go one space to the left. So we're going to be left with 0.534. And again, let's imagine what's 10 to the minus 2? Well, it's just going to be the reciprocal of 1 over 10 squared, or it's going to be it's the reciprocal of 10 squared, and that's just going to be 1 over 100. 1 over 100, and if we wrote this as a decimal, it would be 0.01. So one more time, what would, if we took this example of 5.34 times 10 to the minus 2, what would this look like if we just wrote it without our scientific notation? Well, again, we're just moving our decimal place to the left, and we're moving it 2 spaces to the left. So this would be equal to 0.0534, because we're taking this point, and I'll just move this, taking it, it goes here, goes there, and we need another 0. So that's what it would be. It would be 0.0534. And you can imagine that if we had a number, so if we had a really small number, something like, I don't know, something like, how about 7.26 times 10 to the minus 12, something like that. So that means we have to move this decimal place over 12 different spots. So if we were going to actually write this out, it would take us a while, and we'd have to concentrate on it. It would be 0 point, so we need to have 11 leading zeros. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then our decimal place moves over 1 point. 7.726. Sorry about that. So if we were going to write this out, you can imagine our decimal point started right there, right? We had 7.26, and we had to move it to the left 12 spots. We moved it once, twice, three times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times, 12 times. So that's where our decimal point goes. And you can imagine that if we had to write this out, if we had, say, this number, this really small number, somewhere in a calculation, and we had to write out this with all these zeros every single time, well, first off, we definitely make mistakes, And second, it would take us a lot longer to write out all the zeros. So hopefully that gives you a little bit of information. The last thing I told you about scientific notation was that it helps us keep track of significant. Sorry, I forgot how to spell significant for a second, but it helps us keep track of significant figures. And this is what we're going to talk about in the next video. So anyway, hopefully you found this useful, and I'll see you in the next video.